Hi guys, so today we're going to go over the chain rule, which is a method of finding derivatives when you can derive more than one thing at the same time. So for instance, for this question, I have x squared plus 1 to the third power. Well, I could derive x squared plus 1, but then I could also use the power rule for something to the third power. But I can't do both at once. So in comes the chain rule. So notice dy over dx equals the derivative of y with respect to u, dy over du, times the derivative of u with respect to x. And if I were to divide out du here, it still leaves me with dy over dx. So notice that everything I'm going to do, I'm going to implement a third variable known as u, but it will only be within the work. It won't be in the answer itself. So hopefully I can explain this a little better with the example. So I'm going to start off by replacing one of these many things that I could derive with just u. I'm going to bring down to the third power. So this is a little easier to derive, just u to the third power. But again, let me create a sidebar here where I note that u is x squared plus 1. So if I take the derivative of dy with respect to u, this is dy over du, it would give me 3u to the second power using the power rule. So again, this is dy over du. I need to multiply it by du over dx, meaning the derivative of u with respect to x. Okay, well, I have u, so what's the derivative of u with respect to x? So I would just derive this. Using the power rule, 1 times 2 is 2. X, take 1 away from the power is 1. I don't really need to write that though. And then the derivative of any constant is just 0. So I have dy over du here. Now I just need to multiply it by du over dx, which I have, and that's 2x. And that will equal to dy over dx. Okay, so I have this, but again, dy over dx means the derivative of y with respect to x. So this function should only be in terms of x. And I have this variable known as u here, so what do I do with that? Well, I know what u equals to. U is equal to, trying to color coordinate, so bear with me, x squared plus 1. I'm going to bring over the square. I'm going to bring over the fact that it's being multiplied to 2x. And this is actually it. We're done. The only thing I'm going to do is clean this up because I can multiply 3 times 2x. This would give me 6x times x squared plus 1 squared. For those of you that are trying to distribute, don't do that. Remember exponents before multiplication, PEMDAS. So you would have to actually expand this by multiplying or foiling x squared plus 1 times x squared plus 1 sidebar and then distributing the 6. But I believe in most of your work you'll see the answer in this way. All right, guys, I hope this